Hello everyone, I'm back with another video. This is the third part of my regression video. So previously we were actually seeing the code of this California housing dataset in my previous video. So now we'll discuss about the remaining part of the code here. So as you know, we have visualized the data, we have done check the correlation value for all the variables. Now we will prepare the data for machine learning algorithm. So previously we have seen that for total bedrooms there were some missing values. So for the train, if we again, so now from the training set we'll have to drop the median house value because we don't want the model to see the predicted value or see the our target value, right? So in machine learning, uh, actually we don't, so we are dropping the median house value level for the training set here, and then we are just checking that there whether there are any null values. Actually for test set there will be no median house value because when we will predict we don't want, we want it to predict the median house value. So here we can see the row. So if we see the total, so there are lots of options for this bedroom missing. We can actually perform a lot of like actions. So there are some options that we can do to get out of this error of missing value. So our first option is to remove the whole, actually the whole column. So do you think that this is a good option? So here in this sample underscore incomplete underscore row, we are saving all the rows which have null values in this method. So do you think that actually it is a good option to delete the whole row or whole column? So in option one we are actually dropping the rows, and then here we are dropping the columns. So actually dropping the rows or columns so that values could also be important. So dropping a whole row or column is not actually a good option in this case because this bedroom also contributes much more for the prediction of median house value. So another option, third option is the best option because here we are filling the null rows with median values of other, with the median value from the top or the bottom rows. We are using the top and bottom row value. We are calculating the median value for total bedrooms, and then we are placing those median values into the missing value rows. So actually that is a good option. Previously we are seeing that there were null values. So now we are seeing that a median value is placed, like 433 is placed everywhere there is missing value. So that is actually a good option because if you see the other total bedroom values, so there are values like 412, 433. Okay, so like if we check our bedroom values from previously, so there are like values like 433, 474. So 433 is a like a good approximation for the missing value. So instead of, so there are 10,433 rows are already there. So if we drop the whole column or the rows, that is not a good option because maximum data is there. For just like 200 rows, we cannot delete the entire row or some columns. So this is one preparation for training. So another preparation is we will have to handle the categorical or qualitative values because our machine learning model don't understand the categorical values like question proximity, so it cannot work. So it has to be something numerical, so we can actually convert it, like there are some classes, so we can convert it into some numerical values using sklearn imputer, simple imputer method. So here we are using that imputer method to encode, to apply. We will apply something called hot encoding later on. So if we apply, if we see that this is like the option, so if we apply the ordinal encoder, so it will actually encode, say, one near ocean for 20, inland for one. So there were probably four or five different possible categories. So it will say it will one each ocean will be encoded as 1 0, inland will be encoded as 1, then island for 2 and 3 4, this way it will be encoded. So the machine learning model will be able to get, it will get numerical values for training. So we can also apply one hot encoder as well instead of categorical encoding or ordinal encoding. So one hot encoding actually takes more spaces, like it creates more columns, and for that, and for which column has the value, it actually creates a column matrix. In case of categorical encoder or ordinal encoder, it creates a simple column, but it creates a column matrix, so it takes more space and pro- places one in which there is a value present. So here in this case we are using categorical encoder. So we are also adding the our extra attributes here: room per household, population per household, etc. Then we are adding those stuff, and then we are using a scalar pipeline class to create a pipeline using imputer and standard scaler also are there to scale the data to a certain range. Then we're creating a pipeline for our training. So this is all the pipeline codes for training. Then we will select and train our model using linear regression. So linear regression, as you know, is a popular, it's a popular regression model. So we'll feed our data. This is what we got after the pipeline part. So now you can see we get some prediction values, now some predicted levels, which is compared with the actual values. So we can see that if we calculate the mean squared error from linear regression, we get this value. So there is a huge difference between, actually, between the predicted value and actual value still. Also, if we use mean absolute error as our matrix instead of root mean square error, we get this value. So this is still high. And if you use decision tree regressors, surprisingly there is zero. Actually, the difference is zero. That means it is predict 100% accuracy of prediction. So this is highly unlikely. So we will next see that probably there is something like overfitting. So this is highly unlikely that is predicting 100%. Now So we will fine tune our model using cross validation now. So what is cross validation? So cross validation actually divides the data set here into, like, so since the CV value is 10, so it is dividing the data set into 10 parts. For every time it is alternating, so every time it is actually taking one part as test set, and the remaining nine portion is kept for training. So in the first iteration it is taking, for example, the first portion as test set, and then the next iteration it is taking the second portion as the test set, and then third portion, then fourth, then fifth. Likewise, this is how it is working, and the remaining portions are used for training. This actually helps to, like, we are taking all our portion as test set every time, and this actually improves the accuracy. And so this is a good method to train. So we are now getting this sort of accuracy. So let's see if we can improve it more using random forest regressor. So actually random forest is an ensemble of decision tree. So decision trees are like tree-like data structure which is popularly used in machine learning. So I will try to make separate video explaining decision tree and random forest later on. So here we are again after. So here after using random forest, there is a mean is now much lower, so it is more accurate right now, giving more accurate prediction. So we are also trying another other algorithm like support vector regression, but it is giving a higher value for root mean squared error. So that means not much accurate. So there is another concept in machine learning called grid search CV, or grid search cross validation. So what it does, it uses the cross validation to search for the best parameters or the best hyperparameters or features which will produce the best accuracy. So we are using random forest regression and grid search CV to find the best parameters which will produce the best output. So we are getting from here that max, if you use a maximum features of 8 maximum features from our 10 features, and also 9 in underscore symmetry value 30, then our accuracy will be the maximum. So now we are using that best parameters to again train using cross validation. So these are the outputs. So I think now we should get a better accuracy, because actually what happens is that if we don't use cross validation or grid search CV, we will have to tune our hyper parameters every time. Like after 40 epochs, after 2 hours of training, you see that I can change a hyper parameter to increase the accuracy. So it is like really time consuming. So if we just use randomized search CV or something called like grid search CV, we can actually run it once, and then we will know that these parameters and these hyperparameters will give us the best accuracy, and then we will use that parameters to run the code again. So actually in 2 or 3 steps we can train the model. But if we, like, search it manually, that which are the best parameters for us to get the best accuracy, this is really time consuming, and also resource will be consumed much more. So in this way, actually using grid search CV and random search CV, we finally get a low RMSE value. That is, it has a 95% confidence interval for test values. So if we use that for test, so actually we have used it for test data, and we see that we have seen the lowest root mean square error. That means the difference between the actual value and the predicted value is also less. So for confidence interval, we have calculated z scores, which also gives good some good output. So this is all from my regression video. If you have any further questions, you can ask in the comment. That's all for today. Thank you.